So that involves using either Moodle or the wiki. I'd much prefer the wiki. Okay, so what I need you guys to go do now is jump onto the wiki, or you don't have to do it right now, but if you've got your computer out right now, let's go to the wiki. I want you to make an account. I'll step through making an account. It shouldn't take much effort. Don't say it, or otherwise the robots will hear, and they'll know what the answer is. Okay, so if you go to strangercollective.com/code, and then you go up to the top right and select Create Account, that'll give you the opportunity to do a maths problem. If you can't do it, then you can't submit. You're not allowed to submit. Whoa! 10 plus 20, can't answer that. Not allowed to submit. I honestly don't care what your username is. I don't care what your password is, obviously. Just put in your real name. And you should be able to create an account. And Julia, you can obviously be allowed to do that as well. So the key thing here, before you go to submit, all of these names in the students assigned are going to be red. So Stephen, is Stephen here? No. Cool. Good. Okay. So I've made Stephen red. What that means is there's a link in the wiki to a page called Stephen Karahalias. And when we click that, it's going to take us to a page to actually create the Stephen Karahalias page. So the key thing here is I want you to, those of you who have logged in, are you capable of editing right now? Is it allowing you to do that?
Yes.
Or is it, so it says edit, or it says just view source? Okay, so please do not, like if you start fucking with my main page, just know I'll know who did it, and I can revert back. So, huh?
But I didn't bother to revert back.
I can revert it. I guess right now we can crowdsource this, so I don't have to go through. If you go to the students assigned section, actually no, don't do this because you're all editing at the same time. If you actually create a page, so for example, Alan, if you were to write your name into search and hit enter, that's going to say there's no such page as Alan Wang. And then if you click on that, it will then allow you to create that page. In here, I want you to submit your PDF and your Rhino file and your script. Cool. So the way that you would do that is you would select embed file. It's going to ask you what the name of that file is. So in this case, I'll call this script.gh. Then when we save the page, Alan, have you been editing your page? If I go back in, I'll type script.gh, save the page. So we can see that there's now a red link. So every time you see a red link, that means there's something that doesn't exist, but you have an opportunity to add it. So if I now click the file script that then gives me the opportunity to upload that file. Cool? So you can structure which files you want to upload, you make the links for them, then you just click each link and upload each file to those links. Sweet?
Does this mean everyone that searches your name can edit in your page?
Yes. I will make it so that only you can edit your page. Are you worried?
No.
Are you worried about James?
No, I'm just
Not that James, there's another James.
okay.
Where is he? He's not here?
The only James I know.
The other James.
There's only one James.
Yeah, I would be worried about Julia and me going in and like messing things up, and we won't.
I'm asking like for myself so I can edit someone.
You want to go edit someone else's page?
Like
The thing is, does everyone trust each other? Yeah. So the thing is, it's gonna take me a bit of effort to go through and like say, okay, only this person can edit this page. But the thing is, if you think someone's done something to your page, just let me know, and we'll do something about it. Cool. So feel free to write any notes or whatnot on your page for that assignment. If you like, for example, we get a lot of emails from people saying, "Oh, by the way, like just make sure to check here." Like you can leave it there, and this is a really easy way for Julia and I to both get this information, and this is also a really good way for you guys to eventually start asking us questions about scripting. I haven't received a single email about scripting yet, so that means everyone's going, "Huh? Did you email me?"
No, I just didn't know why.
Why? Because you haven't started. So I'm going to get a whole bunch of. I'm going to. Huh?
It hasn't started.
So I'm going to get a whole bunch of emails this week. Is that right? Okay. Right. Yeah.
How do you remove the portion of the code? Just to keep it the same.
How do you remember what?
Portion.
A portion.
Portion.
The torsion.
Yeah.
What do you mean?
Like keep it the same because what's happening is that like if I'm putting like a rail curve, it's like going along the curve, but since the curve is like rotating itself, it moves. to
Right.
something else.
That to me sounds like you need to do a loft instead of a sweep.
But a loft keeps it at the same direction. So if I do a rectangle and it goes like
So when you do a sweep,
yeah.
the sweep's banking as it goes around corners, right? And you don't want that.
Yeah.
Right. So how is a loft any different to a sweep?
Well, but the loft doesn't. Well, because the sweep actually.
Just think about it. So if you've got a line and a sweep, you put the curve at the beginning of the sweep and you go, off you go, and it does its job, right? Versus a loft, you would put the curve all the way along, your profile curve all the way along your curve. That would give you the complete and absolute control that you want to stop it from banking as it goes around the corner, and then you loft it. Yeah? Right. There are a few other options with rail curves. There should be an option for how it goes around corners in the sweep. Shall we talk about it in class? Was that you just saying, hey, I actually have a question?
Yeah.
Okay. So, but just to sort of like demonstrate, this particular environment is not good for answering 40 people's questions. It's actually really good to answer that outside of class with, like, I can get your script. So when you submit scripts to me for help, don't send me screenshots, send us the actual script. We can actually write the solution for you, write notes into it, we can throw it onto the wiki, and everyone can see the solution, right? So writing me an email with a link to a page that you've made on the wiki with the question, that's great, because that then gives everyone an opportunity to also see what's going on. Yeah? Cool. Now, I actually haven't prepared any lecture for today, because normally today is the day that I introduce assignment 2. So I was thinking about going over some of the stuff that we learnt last semester, because a few people have complained that they've forgotten everything. Is everyone forgotten everything?
Yes.
Not everyone. So it sort of breaks down into four things, right? And the thing is, the 4 assignments that you did are quite important because they really should have fed into some key aspects that are usable now in your cinema. So, and as well, it gives me an opportunity to tell the students who weren't here last semester what you guys learnt. So, you have 4 assignments. You had a letter, you had a waffle, you had an attractor script, and you had your finger joint system, your spider clamp. Right, so what are some key concepts that you did with the letter? We dealt with just drawing shapes in 2D, extruding, but there were 2 sort of like computational methods that most of you guys used in that. And that was with finger jointing and living hinge pattern. Right. So what enabled you to make a living hinge or a finger joint system? There were 2 components that allowed those to happen really effectively. Anyone?
Series.
Right, okay, yeah. Getting you in that direction. Series? No. So if I were to divide a curve up, if I were to take a curve and change my pen, if I were to take a curve and start turning that into a finger joint, we would have to break that into segments, right? What do we have to do to that list to start making it finger joint? We've shattered it. What next? Divide it. Keep going. What's the next step?
Dividing it into each individual segments.
Right. So if I want to, the outcome is this. If that's you Booleaned it, did you?
You can.
Right. Okay. So if we've got a curve like this, and we want it to outcome like this, is there a pattern to that? Can you see a pattern? Can you see out, in, out, in, out, in? There's a pattern, right? You could define that instead of out, in as A, B, or true, false, or 0, 1. Okay, so everyone here should have used dispatch for finger jointing. Dispatch? No one? Okay, we're going to have to teach people about dispatch. My class have to say yes? Yes, okay. Then when we pull them back together, what's the opposite of dispatch? So if I dispatch you guys, right, I'm going to treat this core row here, not you two, as a list. You are now a list. Yep. So your item 0 and your item 1 and 2 and 3 and 4, etc. Right? And I'm going to put a dispatch pattern of A, B, or true, false, or what else could true, false be written as?
0.
Or 1, 0? Yeah? So, Romany, you're going to be A, true, or 1. Let's go with true. So you're true and you're false, right? So Tom, your name, say it again. Suras, you're true, right? At what point what is Tom? What is Tom going to be? Correct. True. Now, if I were to say everyone in this line who's true, because I don't actually have to assign it, you're clever enough to know. if I were to tell everyone who's true to actually stand up and stand in that corner, and everyone who's false to stand up and stand by the presentation desk, you're all capable of working that out, right? That's a dispatch. We've taken a list and we've assigned a pattern to that list, and we're separating the list by dispatching it. Cool? Does that make sense? Okay, so if I were to make this pattern instead true, false, true, so it goes true, false, true, true, false, true, true, false. Do you see how the result could be different? So you can control how your patterns work, and there's logic within that. Now, this is very important to understand as we get to our fourth assignment. Is this all coming back to people? It's all coming back? Yes? Okay. Interactive. I need nods. I need yeses. You're the number star. You're star. You're always responding. Okay. So, what could be the opposite of dispatching? I'll just say it now. It's weaving. We don't have enough time to wait. So, weaving. If I were to now take two lists, let's say I take U4 as one list, and this group of people here as 4, and you are 0, 1, 2, 3. 0, 1, 2, 3. And we use this pattern of true, false. If I were to do the opposite of dispatch, who would be first? Your list A and your list B. Or you are list 0 and you are list 1. Who comes first? If I write a list of everyone, who comes first? Who's first in your list? Daniel? I'm just going to do a D. And who's first in this list? Romany, right? So if I were to merge these together, this is list 0, and this is list 1. And I'm using a pattern of true, false, or 1, 0. In our woven list, who's first? Are you sure? Romany is 1. Daniel is 0. I'm just playing with your brain, mate. Are you sure?
I think so.
Yep, so it goes Romany, then who?
Danielle.
Right. Now I'm going to keep you rolling with it. Who's next? Sophie. Sophie, then who?
Chris.
Do you guys get it? You getting it? Cool. Okay, it's the opposite of dispatch, right?
Okay.
Cool. So this is the exact system that we used to do finger joints, and it was the exact system that we used to do living hinges. For those of you who cannot remember or do not know what a living hinge is, it's effectively a pattern of off and on with curves that were laser cut into your plywood that allowed you to bend that plywood around a corner. Cool? Okay. So that technique is almost the exact technique that you would use to draw a section for stairs. So instead of dealing with it as a finger joint, if you had points like so in a line, if you define that as a line and you divide that line up into points, and you move these points up as a separate list. So we've now got list 0 and list 1. Can you guys see how we can start to weave those together to make a stair? Yeah? So list 0, so if we say list 0 and 1 and we use a pattern of 0 and 1, we can weave these together and draw a staircase, right? Now, most of you are doing fairly typical cinema layouts, right? Most of you, not all of you. Can you see how this could be useful to do the actual plats of a cinema? Shall we do that now?
Yeah.
Let's do it?
Yeah.
Let's script it. Sorry. Is this going the wrong direction? Are you happy with this type of going over this? Okay, good. So I'm going to be quick, okay? Because you guys should be able to keep up. Most of you should be able to keep up. Sophie and Romany, have you been utilising James Stevenson at all? No? Okay. Whoops. Okay, so I'm going to draw this from a front view. So just consider this is going to be like a 3D thing. It's not something that sits on the XY plane. I'm going to draw a line. Now, there's obviously a lot of scripting that could be involved in making this like a standard staircase. So there's obviously rules to how deep a step can be. We're not going to get into that too much. We're going to bring that line into Grasshopper, and I'm just going to bring bifocals in as well because bifocals is useful. And everyone should be familiar with dividing curves. Yeah?
Yes.
Good. I'm loving it. It's good. Right. So, as you saw, when I moved this point up, if I move it up too high, we get like a weird sawtooth effect, right? So at what height do we want to move those points up? Quick. Pardon? The height between these 2 points? Yeah? So how do we get that? What we could do is we could just grab the 2 points. We could grab the first 2 points and find out the height difference between them. Do I need to explain what vectors are? Everyone familiar with vectors? Yes. Sophie, you know what a vector is? Brilliant. Maths, people know maths, good. Okay, so with list item, we want the very first point on the curve, and we want the second point. Now, the super easy way of getting those two is by just zooming into your list item component. It's going to give you these little black pluses on the top and bottom. And what that does is creates an offset selection for the item that you put in. So the default for list item is item 0. And item 0 plus 1 equals... No, come on, mate. Item 0 plus 1 equals 1, right? And item 0 minus 1 equals... Sorry, item 0 minus 1 equals...
Yeah, 0. Nothing.
Item 0 minus 1 equals minus 1. Now, for those of you who have forgotten, if I have a list of people, so there's 1, 2, 3, 4, 5, 5, 10, 11. If I've got a list of 11 people, and your item's 0 and 1, and James's item 11, if I say pick out item 3, we get Suras, right? If I say pick out item minus 1, where do we go? There's no one here, right? So what we do is we go to the end of the list and we get James. Cool? So we want item 0 and 1, and we're going to grab the vector between the two of them. And the reason we're doing the vector is because vectors are defined in a really nice way. And that is, they're defined in their x direction, their y direction, and their z direction. So we can quite easily deconstruct this vector and just get its z amplitude, which is coincidentally very close to 1 for me. Cool? Yeah, you're cool? Everyone's cool? Yeah. Yeah, relevant question.
What's that like 3ms percentage in the bracket thing?
Ah, that. Okay, so this is a little widget that I use and that most of you should be using. You can find that under display canvas widgets, and it is called Profiler. What it does is it tells you how long your component is taking to do the thing that you're doing. So in this case, when I make this vector, it's only taking my computer 3 milliseconds, and that happens to be 3% of the total script's time. It helps you work out where, like, let's say you've got a script that takes 10 minutes. Maybe you've got a component in that that takes 9.8 minutes. You know which one that is. Yep, that's fine. The thing is, when you've got, like, look, this is taking up 62%. So when you've got a small script, obviously the component that takes 48 milliseconds, it's going to be the most troublesome one. You're fine, right? Your script's probably only taking like less than 100 milliseconds to run, right? Okay, you will eventually have to deal with this when you're doing a stadium, and you'll need to know which component you want to turn off. Yeah? Okay, so we've got a Z unit. We're going to turn that into a Z vector. So we're going to use the unit vector component. So that just constructs a nice vector that just contains the Z. And we're going to move all our points up. So we're going to use the move component. We're going to grab all our divided points. We're going to give them that vector. And we've now got those two lists. Cool. What's really good is this would have taken me 4 hours to explain last semester, and now it's only taking me like 10 minutes. Cool. Okay, so we have two lists, and we have a weave component. Weave is here. You can find weave under set in list. Remember, put your hand up to tell me if I'm going too fast. Okay, so we've got our weave. Now, the default weave pattern is actually sitting in this P. And if I mouse over it, you can see it's 0, 1. Yeah? So if we just work with the default, what should be going into 0? Which list? The list that has been moved or the list that hasn't? Okay, so the list that hasn't, that's probably 0.0, and that's 0.0 of the second one. So let's do that. Let's plug in the list that hasn't moved. So that's the list of points into 0, and that's the list of points into 1. And obviously you won't actually see any changes yet because it's just displaying. Yeah? So now let's put a polyline, put these points into a polyline, and we have a nice stepped stair. Am I dealing with things too simple for you guys? Or is this am I targeting the right stuff? Just right? Okay. So, because this is linked to this curve, I can actually start playing with that curve, and we should end up with whichever divisions that we are looking for apply to that curve no matter what. Cool. Now, probably the last thing I need to fix is the fact that we've got like a thing sticking in the air. So what item in our woven list would that stuck in the air thing be? Yeah, so the last one? Yep, so we can identify that through -1. So let's use our cull item, cull index. So we're going to cull the very last item in our list, which is -1. And now we no longer have a little doobie stuck in the air. Cool? So who actually can, and I need you guys to participate in this question, who actually used Weave and Dispatch last semester? So you guys didn't? So how did you guys do the finger joints with your letters?
They use dash
Wait,
pattern.
pardon?
Dash pattern.
Yeah.
But how, so they offset and then dashed.
Yeah, I'm not really sure. Rebecca kind of gave them the script.
Right.
I'm not sure how many of them actually input, like actually took it
Elliot's class?
in. We didn't do big, at least I didn't do big.
Right. What about living hinges? How did you guys do living hinges?
We followed the
Right.
same script.
So, can you know what a living hinge is? Can you see how this system could be used to do a living hinge? Yeah? Okay. Right. So second assignment was the waffle. It was very much about you guys making 3D forms and cutting through it. Yeah? What did you use to cut through your waffle? Pardon?
Rebecca,
Oh,
yeah.
fuck this shit.
Yeah. I had lots of opinions about that.
Yes, so do I. I clearly have a lot of opinions about it because I'm now... Right. I only know 3 people in this class who actually used sections, like actually intersections with stuff.
Oh, right. Like did it the proper.
Because they were in my class. Shit. Four people.
Yeah, I showed you, right? Yeah.
Okay.
It was one person.
Well, we don't have to deal with that so much right now. But you guys must have done, you've had to do an attractor script, right? So in your attractor script, how many attractor points did you have? Now, let me just clarify a few things for people who don't. I'll just reiterate what an attractor script is. If each of you are a point in space, you are. Let's imagine your brain's your point in space. And we have a proximity to each other. So if you are a cloud of points and I am a point that affects you, then you can quite quickly work out how far you are away from me and you can do something. So, for example, you could put your arm in the air. A lot of people should be very familiar with this example. You put your arm in your air as I get close to you, right? So if I'm within 2 meters of you, stick your arm up. If I'm within 3 meters of you, you can have your arm down. And if you're in between, you can put your arm in between that. So if we start that right now, right? Yeah, you're good. And as I move away, you guys should gradually move your arms down, right? Yeah. Okay, so you're getting it, right? So you're just testing distance, and you're testing that distance, that proximity, and you're converting that, you're abstracting it into sticking your arm up. Like, it makes you look like a fool, but it makes sense, right? So what happens when 2 attractors come into the equation? So when Julia, do you mind getting up and moving around? When Julia comes into the system, you also have to start sticking your arm up, right? Someone's ignoring me. Yes, okay, so we're both in the system now. So your brains are actually having to handle the fact that you're looking at the distance between both me and Julia moving around, and it gets a bit complicated, right? Like if I start throwing in more people, like if I tell Lachlan to stand up and be one of those agents, it gets even more complicated, yeah? So you can stop now. So, when you guys wrote your attractor scripts, how many attractor agents did you have? 1. You only had 1? 1. You only had 1. Why? Huh? You had a lot? You had a lot of attractor agents. And how did you manage those to work in the same system?
There were, so I did like list item of my top surface.
Right, okay.
And then divided that into little squares. So there was like one attractor in each square. But that was
Right.
and that's really
So I don't mind that it's ugly. It's interesting to know how you did it though. That's the key thing. So if we all imagine each other as parametric designs, if you start thinking, Julia will actually do a lecture very similar to this idea that each of us has genomes, we have DNA, and really I can look at the structure of your DNA, Chris's DNA, and Zara's DNA, and the structure of that's exactly the same, right? You have the exact same number of combinations, and fortunately you have the same, otherwise if you didn't, or if Zara didn't, then there'd be something really wrong with you, right? So in each of those, they're parameters. They're just sliders that can be true or false, or in this case, I think it's 4. Who's doing Gattaca? How many are there? 4? G-A-T-C. Yeah, there's 4. So they can either be 1 of 4, and when they combine, it's 1 of 4 with another 1 of 4, and that becomes a parameter. So in that, you could be considered a monad. So a monad is something, a simple little building block that's individual and that can change. So the most common monad we ever see every day is pixels. Everyone who's using a phone or a PC right now is looking at monads, right? A pixel is a tiny little square, and it can either be off, on, and when it's on, it can be a range of different colors, right? And in a system of monads, I can even see them here, these little pixels. If I just change the color, or if I have control of the color over each, I can produce an image. I can produce practically any image imaginable using that system, okay? And that applies with humans as well, right? So we play around with the parameter of a human, we get different humans. There's lots of variety. Now, if I were to just create, if I were to just create a system, like a list of all of you, and I start noting down the color of your hair, so I'm sorry I'm picking on this core row, but if I go with these 4 again, so if we go color of hair, Romany has color hair of, I'm going to say you're a redhead. Sophie is blonde. Saras, do you reckon you got brown hair or black hair? Black. And I can't remember off the top of my head your name, man. Tim? You'd say you have black hair? Yeah, okay. Right. So, if I start, that's quite a nice structured list, right? But if I were to start bringing other factors in, so let's say, this is a bad example. Sorry. Yeah, let's not talk about genomes with this thing. Let's just do arms stuck up. Yeah, we'll do the arms stuck up thing. So you 4, you're roughly within 4 to 5 meters of me, right? So the distance is 5, let's say 5 meters. Does someone have it, just throw a number out of how far you reckon these guys are away from Julia? 8 meters? Well, it doesn't really matter. Right. So, do you see how, now that we've added a third column in, things get to become a bit complicated, right? Because how do we get Grasshopper we can get Grasshopper to measure the distance between these 4 points and these 2 points, right? but the way that that distance comes out is quite complicated. Yeah? So if we had a list of the distance between you4 and me, we get a list of 5 in a branch. And if we have a list of your distance between you4 and Julia, brain fart, you get a list of 8. So I'm gonna do that now. I'm gonna just put 4 points down, just to demonstrate. 1, 2, 3, 4. I'll turn the grid off. Is that easy to see the points? It's quite hard for me to see them. Oh, whatever. Grasshopper will make it easier. I'll grab those points. And then I'll put 2 more points in. So this is me and this is Julia. So what we get is a list of distances for the 4 of you with me, and then a list of distances with the 4 of you and Julia, right? Now, you would have noticed I did something a bit funky there. I actually grafted the information as it went in. Everyone familiar with grafting? Yes. If I don't get a nod, then I assume that's a no. No? Grafting? Obviously no. Kind of no. Right, okay, so we might do a bit of a workshop upstairs about it. The key thing is, the way Grasshopper displays this information is in a list, and that list is split up by this branch system, right? So you could think of Grasshopper as actually showing you a graph. It's dealing with the first column, and then it's dealing with the second column, and it just has to give it to you in this system, right? So when you have a structure like this, we can think of that as a 2D matrix, okay? So Grasshopper always considers anything in a branch or a column separate to another thing, okay? We've got time. 5 minutes, we'll do it. Okay, so if you guys are in a branch, and those 4 are in a branch, and you're in the same list, do you know anything that's happening over there? No, you don't, right? Because there's a branch system in the way, right? So, you guys, using this system, you can only concentrate on either me or Julia. And in that system, do you remember how she was walking along and you were capable of actually focusing on both of us? That's inappropriate. This doesn't work that way. We actually want you to be able to focus on both of us at the same time. So, can anyone think of a physical way, except for those people in my class, because I know you know the answer, can anyone think of a physical way to turn that? Now just remember, Grasshopper can only focus on the columns. How can we turn that so that Grasshopper can see both Julia and me per item? So Grasshopper can only see this column, and it can only see this column. But we want it to be able to see this number and this number together. What could we do to the graph so that it can see it? Cross-reference? Okay, so just physically, what could we do to it? So, right, so this is a column, and instead we want to be able to say, turn the rows into columns, right? So we see row, obviously they're all going to be 5, 8, 5, 8, 5, 8. I think we probably need a bit more than 5 minutes to explain this. The key thing is, yes, you're right, it's flip matrix. Who told you that? Was it James? So when we flip the matrix, what it does is it puts Neo on his side, and it basically turns rows into columns, okay? So now we can quite easily sort these. Is this coming back to people? No? Thanks, Rebecca. So we can sort these to get the shortest distance. We can pull out the shortest distance. And so now we've got that the shortest distance. So remember how, like, even though I was standing over here but Julia was there, these guys stuck their arms up because it didn't matter how far I was away. You still have to focus on Julia. This was how you did that, logically. Right? You put Julia, the distance of Julia and me in a list, and you worked out which one's closest. You worked out how far that distance is, and you used that to define how high your arm stuck up. Right? But if I were to then take a snapshot of what was happening in everyone's brain, it would look like that. It would look as like a flipped matrix. Does this make sense?
Yes.
Okay, good. Okay, so the key thing here is that this doesn't have any direct application to what you guys are doing. It has complete, total application to you learning how to do scripting, okay? If you understand this is what I define as understanding, moving from a beginner user to an intermediate user, okay? So at the end of this course, you guys need to understand trees, branches, and matrices, okay? And we're going to go over that more in workshops. Not today. Today we're going to focus on the assignment. But I just want you to think, are a lot of you copying and pasting your scripts? So if you have one staircase, are you copying and pasting the script to do with a second staircase? What? If it's what? Right. But how could you write your script so you don't have to copy and paste the script? You just allow the system to do two staircases. So you guys have transcended manual work, right? Someone would have sat there and drawn that stair. But now you can script the stair. Now, anytime you have to do a stair, you've got the script. Problem is, you haven't transcended the manual labor in scripting. Do you get what I mean? Yeah. So you want to be able to write scripts so you don't have to rewrite scripts. Okay. Let's finish this assignment upstairs. And just be prepared for next week's lecture, which will be on the next assignment. Then the week lecture after that will be Julia talking about... Pardon? Yes, let's do emergence, which is very much about those monads. So monads in emergence, very important.
Living systems and how they can be applied to architecture.
Next week in class, we'll do some more of this, okay? Because I can't believe how little you guys have done. It's not your fault. Pardon? It's an Autodesk program. It's an Autodesk program where you put geometry into it and it automatically cuts it up for waffling.
It's not alternative.
Well, so my problem is, I taught my class how to do it with Grasshopper because the technique you could then use to apply to a roof or you can build stuff. Thing is, you cannot put a roof design into 1, 2, 3 make and then have it do that, and then you go, oh, here you go, builder. Here's all the information you need to build something. Do you have a question? Was that you putting your arm up?
Oh, yeah.
What's the question?
So, for the in our company,
Could you talk up a bit?
like, so the first thing you did on the screen,
The stair.
I mean, the list item, well,
This one?
The list item first.
This one? This one? You zoom in. It's a little black plus at the bottom. Press it. Did everyone else get that? Pardon?
My second part of that was up to the and the color again.
Right. Did you have wrap turned off? Okay. Shall we look at it upstairs?